assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
So here for part A, we know that the amplitude of the acceleration, a sub m, would be equal to omega squared times x sub m, the maximum displacement, where omega is the angular frequency. This would be equal to 2 pi f. Knowing we can simply substitute this in, and we see that the magnitude, the amplitude of the acceleration rather, is giving us 2 pi times 10, rather, sorry, my apologies, 1000 hertz quantity squared multiplied by 0.00040 meters, and we find that the amplitude of the acceleration is equaling 1.6 times 10 to the fourth meters per second squared. And so for part B, similarly, the maximum speed is going to be given to us by omega times the maximum displacement. This would be 2 pi times the maximum displacement times the frequency. This would be 2 pi multiplied by, again, 1000 hertz multiplied by 0.00040 meters. And we find that the maximum speed is going to be 2.5 meters per second. For part C, we're going to use equation 15.8, and we have in absolute value, absolute value of the acceleration would equal 2 pi times 1000 hertz quantity squared multiplied by 0.00020 meters, and this is giving us 7.9 times 10 to the third meters per second squared. So this is your answer for C, your answer for B, your answer for A. For part D, now, can be approached with the energy methods of section 15.4, but we can also use the trigonometric relations along with equation 15.3 and 15.6. So here, we're going to use trigonometric relations, so essentially Pythagoras theorem, and then we can say that we can use equation 15.3 and equation 15.6. So essentially we're saying that sine of omega t plus the phase constant phi would be equal to plus or minus the square root of 1 minus cosine squared of omega t plus phi. And this is essentially going to give us negative v over omega times x sub m. This would be equal to plus or minus the square root of 1 minus x squared, the x position, divided by the amplitude or the maximum displacement squared. Taking the absolute values and then simplifying, we find that here for part D, absolute value of v would be equal to 2 pi times the frequency f times the square root of x sub m squared minus x squared, and we can solve. So 2 pi times 1000 hertz, and then this would be multiplied by the square root of 0.00040 quantity squared minus 0.00020 quantity squared, extend the square root. The units here would of course be meters, and we find that the absolute value of the velocity is giving us 2.2 meters per second. This would be our answer for part D. That is the end of the solution. Thank you for watching.